Okay, welcome to my mini lesson on lichen as bioindicators. We talked a couple of weeks ago about how lichen can be used here around the state of Maine regarding the 3 different types and how we're a lot less likely to find lichen in general, like around the cities, but as you get out into cleaner air, you get the crustose, the fruticose, and the foliose lichen. And so today we're going to do a little bit of chemistry with these lichen. It goes a lot more than just whether the lichen are there. So basically, let's actually pan over here for just a second. So we've got set up 6 pieces of lichen in 6 different chemical solutions here, ranging from our regular old drinking water to water with NaCl, sodium chloride, also known as salt. And we have potassium chloride, which is also another type of salt that's used for salting the roads. This one here, CoCl2, that is cobalt. And this one is copper, used for making inks and varnishes and fertilizers. And finally over here we have iron, Fe is iron. And so we are going to be kind of taking a look at whether this lichen can be a good bioindicator of the presence of these, they're called metal cations. If you've taken chemistry, you might remember that a cation is a charged ion. And when they have a charge, they are attracted to other things. So I've made my little data table here, and we're just looking at what the different types of metal cations are. And we're going to be analyzing the intensity of the blue color, which is going to be an indicator of how much cation exchange there has been with the lichen. So the major idea here is that they can actually use lichen in a lab to analyze like a sample of water to see if there are different types of metal cations that are polluting the water. Many of these pollutants came from the air as air pollution and then settle down into our watersheds and become then water pollution. So if over here is the general gist of the experiment. So basically I had a piece of wood with lichen on it, and it said peel off approximately 1 centimeter cubed of, actually no, not cubed, squared. This is just flat, so 1 square centimeter of lichen. And then soak it in this very strong blue dye called methylene blue, which is a cation itself, and you have to soak it for 30 minutes. Just to make things efficient, I already did that part so that you didn't have to sit here and watch 30 minutes of it soaking. So then I took them out of the methylene blue, removed it, set it on a paper towel, and it like really absorbed, and I took a picture of that. Don't look over here. This is like what it looked like after I set the little pieces of lichen on the paper towel. It like absorbed a lot of the stain, and then it said rinse briefly. So I rinsed them, and then I put them all into their own cups over here. So then the last thing we have to do is assess for color and give it a number on a scale of 1 to 5 for its level of like intensity of the blue color. So, you know, as I glance through here, I'm not sure if it might look different as you look at it from the top or the bottom. By the way, this did say to do it in test tubes, but I don't have any test tubes here, so I went with these cups. This is going to be a lesson for you guys because you're going to be creating a lab yourself, and it says to use petri dishes and Vaseline, and you may or may not have petri dishes or Vaseline. In fact, I'd be shocked if you do have petri dishes hanging around at your house, but we're going to figure out a way to do it, and everybody's will be a little bit different. So I would say, Mom, would you say that this one is the darkest, or would you say this one's the darkest? I kind of clearly see that these three are the darkest. This is a really difficult thing to do because we're only making qualitative observations. There's no like real numbers to be able to use here because we just kind of have to make our best estimate. I will say that this one, it has a slightly greenish tint.
Yeah, blue. I mean, a greenish blue, teal color.
Yeah, well, greenish compared to the straight blue. So Fe means iron, right? And iron has that like rusty orange color. So the water or the solution that we started out with actually had kind of a different color to it here. It had like a orangey color. So I don't know, I would probably give this a 5. It's like almost as dark. This is a 5, right? Like this is how it started out. Mm-hmm. I would say that the copper is definitely a 5. Would you say that the cobalt is a little bit lighter than the copper?
Yes, I would say that one's lighter.
So do you think maybe a 4 for this one?
Yes.
Okay. So, by the way, my table is not in order here, so I got to be careful about that. Let's just scroll back to this one for a second, the iron. It's pretty opaque, and even though it has that greenish color, would you give that one a 5, or do you think that it is less dark?
Swirl that blue one around a little bit.
Okay, let's see.
Well, that one kind of does that too. I think I'd give both those a 5.
All right, so iron is a 5. And then going back down here to K, do you guys remember what K is? Potassium. Okay, so let's just compare potassium, sodium, and tap water. Which one do you think you would give the highest number?
Are you actually asking me or them?
Well, Mom, what do you think?
Well, I would say that the potassium is the darkest.
Potassium's darkest at a 3?
Probably a 3.
A 3. And then sodium,
and then
I almost wonder if sodium is the least.
I think it is the least.
The least? Okay. So I'm going to give sodium a 1 and water a 2. Okay? So
these two are almost just alike, but
well, so here's what we've ended up with. We've ended up with 2 5s, a 4, a 3, a 2, and a 1. And I'm going to tell you, spoiler alert, water is supposed to be the least. What we need to know is that the more the blue color came out of the water, the more, here, let's look at me for a second. The more blue the water is, that means there was more cation exchange. So methylene blue is a cation, and all of these metals are cations. And so if the lichen is absorbing the metal, then it has to get rid of the blue out into the water in order to have room for the metal to get absorbed by the lichen. So there should be more blue means more metal was absorbed by the lichen. Okay? Now, I was just saying, spoiler alert, water is supposed to be the least. And it didn't come out the least. this is a really big part of your labs that you're going to have to be doing. You're going to have to really think about possible sources of error. And all along the way, I had to kind of say, like, I don't have test tubes. I didn't have gauze, so I used a paper towel. When you look over here, the directions said rinse briefly. I don't know if I rinsed all of them. I probably should have like counted exactly how many seconds I rinsed them. I feel like that makes a really big difference. So there definitely are possible sources of error all along the way. And we're not really going to be doing much data analysis. This is my grand finale here. We're not going to be doing much data analysis on this. I kind of just set this up to just show you how we can be creative in our homes with the materials that we have. I know you don't have all these chemicals, but the lab that I'm going to set you up with does not require fancy chemicals. But we do have to be creative with the things that we have. We need to think about trying to eliminate possible sources of error. And we really ideally need, another thing is, every piece of lichen is just a chunk that I like ripped off, and it said approximately 1 square centimeter. You know, they're different sizes. They got rinsed for different periods of time. And so there really are some things that if I was to do this again, I have learned some of the ways that I would make this data more reliable. So your job is to analyze particulate matter from air pollution, and check out my next little slideshow with video in a little while to hear about how you're going to set up your final major lab report going through the entire scientific process. I guess that's a wrap on my mini lichen lesson. I hope you were liking it.